This is the most boring photograph NASA ever took. It's also a lie. For nearly 40 years, every textbook, every documentary, every classroom poster described Uranus the same way. A dead, featureless ball of gas. Silent, frozen. The most uninteresting world in the solar system. That reputation comes from a single spacecraft, on a single day, during a single flyby that lasted roughly 6 hours. And in 2024, scientists went back to the raw data from that day and discovered something that should have been caught decades ago. Voyager 2 arrived at Uranus during one of the rarest solar events the planet experiences. An event so unusual it happens maybe 4% of the time. We didn't study Uranus. We photographed it having the worst day of its life, and then wrote that down as the truth. Start in 1781. A musician turned astronomer named William Herschel is sweeping the sky from his backyard when he spots something that doesn't behave like a star. It's a disk. It moves. For thousands of years, humanity knew 6 planets. Herschel just made it 7, and doubled the known size of the solar system overnight. But the strangeness didn't end with the discovery. It started there. Every other planet spins roughly upright, like a top. Uranus is tipped over at 98 degrees. It doesn't spin, it rolls around the sun on its side. Nobody knows for certain why. The leading explanation is brutal. Sometime in the early solar system, an object at least the size of Earth slammed into Uranus and knocked it over. A single collision, 4 billion years ago, that permanently rewrote how an entire world experiences time. Because of that tilt, Uranus has the most extreme seasons anywhere in the solar system. One pole points almost directly at the sun for 42 years of continuous daylight. Then it swings away, and that same pole enters 42 years of unbroken darkness. Imagine a winter that starts when you're born and doesn't end until you're middle-aged. Then there are the rings. Not the broad, bright bands of Saturn. Uranus's rings are dark as charcoal and shockingly narrow. Some are only a few kilometers wide, and that's a problem, because physics says they shouldn't exist. Ring particles crash into each other, lose energy, and spread out. A ring that thin should have smeared into a blur long ago. The answer is a pair of tiny moons called shepherd moons. One orbits just inside the ring, one just outside. Their gravity nudges stray particles back into line, like 2 sheepdogs holding a flock in formation, for millions of years, without a break. So already, before anything gets strange, Uranus is a world knocked on its side, running on 42-year seasons, wearing rings, held together by moons the size of cities. And in 1986, we got exactly one chance to look at it up close. Voyager 2 was never designed for Uranus. It was built for Jupiter and Saturn. Uranus was a bonus, a target of opportunity made possible by a planetary alignment that occurs roughly once every 175 years. The spacecraft had one shot, no orbit, no second pass. It flew through the system at over 50,000 miles per hour and kept going. The first surprise was what the cameras showed. Nothing. Jupiter has the Great Red Spot. Saturn has banded storms. Neptune, 3 years later, would show a dark storm the size of Earth and screaming white clouds. Uranus showed a smooth, uniform, pale blue-green sphere. Almost no visible weather. Almost no visible structure. Scientists expected a dynamic, churning atmosphere. They got a billiard ball. The second surprise was worse. Every planet with a magnetic field follows a rough pattern. The field is roughly centered, roughly aligned with the spin axis. Earth's magnetic poles are tilted about 11 degrees off. Uranus's magnetic field is tilted 59 degrees from its rotation axis, and it isn't even centered on the planet. It's offset by about a third of the planet's radius, as though the magnetic engine sits nowhere near the core. The result is a magnetosphere that doesn't sit stable in space. It wobbles, twists, and reconnects violently as the planet rolls, opening and closing like a valve every rotation. And then came the third surprise, the one that broke the model entirely. Voyager measured Uranus's radiation belts and found them among the most intense in the solar system. Comparable to Jupiter's, strong enough to darken ice, strip molecules, and irradiate anything in range. Radiation belts are made of charged particles trapped in a magnetic field. To sustain belts that powerful, you need a source, a steady supply of plasma feeding them. Voyager found almost no plasma. The system was nearly empty. Powerful belts, no fuel. That contradiction sat in the scientific literature, unexplained, for decades. The magnetic field question came first. On Earth, our field is generated by churning liquid iron in the outer core, a dynamo of molten metal. Uranus doesn't have enough of that. So where does the field come from? The answer lies in what planetary scientists call the mantle, a superheated, superpressurized ocean of water, ammonia, and methane. Not liquid the way we picture it. Under pressures hundreds of thousands of times greater than Earth's atmosphere, these molecules break apart. Electrons are stripped loose and roam freely. That makes the layer electrically conductive, and a conductive fluid in motion generates a magnetic field. Crucially, this dynamo isn't running deep in a central core. It's operating in a relatively thin shell closer to the surface. That's why the field is offset. That's why it's tilted. The engine isn't in the middle of the planet, so the field it produces isn't centered either. Elegant, consistent. It explained the magnetic field completely. It explained nothing about the radiation belts. The belts stayed impossible. And the emptiness around Uranus had a second consequence, one that quietly shaped decades of research. Uranus has 5 major moons: Miranda, Ariel, Umbriel, Titania, and Oberon. Miranda alone looks like it was shattered and reassembled, with a cliff face 20 kilometers tall. Active moons leak. Enceladus at Saturn sprays water into space. Io at Jupiter floods its system with sulfur. Those emissions show up as plasma. Around Uranus's moons, Voyager detected essentially nothing. Conclusion: the moons are geologically dead, frozen, inert, case closed, for 38 years. In 2024, a team of researchers went back to the raw Voyager 2 data, not the conclusions, the original measurements, and asked a question nobody had seriously pressed. What were solar conditions like in the days before the flyby? What they found reframes the entire mission. Shortly before Voyager arrived, a powerful surge of solar winds slammed into Uranus, and it did 3 things at once. 1, it crushed the magnetosphere, squeezing it to a fraction of its normal size. 2, it flushed the plasma out of the system, emptying the magnetosphere of the very material scientists went looking for. 3, compressing the field accelerated the remaining particles, temporarily spiking the radiation belts to extreme intensity. Intense belts, no plasma, both at once. The contradiction wasn't a contradiction. It was a snapshot of a temporary extreme state, and we mistook it for normal. Researchers estimate Uranus spends only about 4% of its time in conditions like that. Voyager had one chance, arrived in a 6-hour window, and landed inside the 4%. Which brings us back to the moons. The dead moons' conclusion rested entirely on the absence of plasma. But if a solar storm swept that plasma away right before Voyager arrived, then the evidence for dead moons was never evidence at all. It was an empty room, cleaned minutes before the inspection. Which means Ariel and Miranda in particular may be geologically active right now. Tidal flexing from Uranus could be generating internal heat. And where you have heat, rock, and water ice, you have the conditions for a subsurface liquid ocean. Liquid water, chemical energy, darkness, the same combination we consider the strongest case for life beyond Earth. 5 candidate ocean worlds, dismissed for 38 years, on the basis of a measurement taken during a storm. The scientific community responded. In its most recent planetary science priorities, the Uranus orbiter and probe was ranked as the highest priority new flagship mission, not a flyby. An orbiter, designed to stay for years, watch the magnetosphere cycle through its full range of behavior, and map the moons repeatedly instead of once. Plus an atmospheric probe dropped directly into the clouds to measure composition from the inside. The travel time is brutal. well over a decade in transit. Which means the decisions made in this decade determine what we know about Uranus for the rest of the century. The deeper lesson isn't about one planet. It's about how confidently science can be wrong when it only gets one look. A single data point, taken on an unusual day, hardened into consensus, and shaped research for 2 generations. Uranus was never boring. We just caught it mid-storm and never went back to check. Here's the question I want in the comments. And be specific. Which of the 5 moons should the orbiter prioritize? Miranda, with that impossible 20-kilometer cliff, or Ariel, with surface features that look freshly resurfaced? Pick one. Defend it. I read these, and the best arguments get featured in the follow-up. If this changed how you think about the outer solar system, subscribe. This channel exists to go back to the evidence everyone else stopped questioning, and there's a lot more of it. Because Uranus has a neighbor. Winds over 1,000 miles per hour, the fastest in the solar system, on a planet that receives almost no sunlight to power them, and beneath the clouds, pressures so extreme that carbon may be compressed into solid diamond, falling through the interior as rain. That one's already up. It's on the channel now. Go.